To problem 45 jump game 2. This is similar to jump game 1. So in jump game 1 we were checking if we could reach the end of an array, but this time we have to find the minimum number of jumps to take to reach the end of an array. So I'm assuming that there isn't any condition there where we can't reach the end of an array, so I'm not gonna add that, but it is similar to the first jump game question in a way that we follow the same logic for implementing our furthest pointer, and then we follow the same statement to check if we have reached the end of an array. So the setup is similar, so we have I and then we have furthest pointer, and there is something called end pointer. I'm going to explain this later. And we're going to carry on with our normal iteration for working out the furthest pointer. So here we worked out the furthest pointer to be 3. So we move our furthest pointer to 3. The thing is, moving to this 4th index may not give us the largest furthest pointer. So what we need to do essentially is we have to check until all of those 3 iterations are complete. So we have to wait until the end of this iteration. So when we move our initial furthest pointer, this is where we are gonna move our end pointer. Okay, and then we are gonna do our iteration. I is here, I is here. Okay, I'm just gonna put down end pointer initially just to see our previous end pointer, and then this is where a pointer gets updated to 7, and then we have another I here. So that's the end of iteration. So by the end of this iteration, we fully optimized our furthest pointer. Good. So this is the furthest pointer we have. So we are going to move our end pointer to here. And then again, what we need to do is we have to look at all the iteration until this point to fully optimize our end pointer. And then when I is here, we update the furthest pointer to 9. And then none of them is good enough to modify the furthest pointer. Therefore, when we get to the end of this iteration, our furthest pointer is optimized. Therefore, we are gonna again move the end pointer to where our furthest pointer is. So this each end pointer basically indicates one step. So initially there has been 3 steps. So when do we update our end pointer? Well, we update our end pointer when I is equal to end pointer. Okay, so that's the logic behind it. Hopefully it will make more sense as we write down the code. Okay, that's the code we have already, but let's write down from the scratch. So we have int int end equals 0, and then we have int farthest is equal to 0. I should have probably put another method for the farthest because I keep making a spelling mistake. And then there is int steps equals 0. And then as I said, we're going to iterate through int I equals 0, and I is less than num star length -1, and then I plus. What we want to do initially is we want to update our furthest pointer. So if furthest pointer is less than num star I plus I, we set the furthest pointer to num star I plus I. And what did we do? When our iteration goes to end, we updated our current end to where the pointer, the initial pointer was pointing. So if I is equal, if end equals I, we said end equals furthest, and then that's when we know we have to take which step to take, so we are going to increase the step. And another thing to do is, if end is greater than or equal to num start length minus 1, that means we have reached the end of an array. So that's when we have an option to return, or can I just break, and then we can say return number of steps. Let's run it. Let's submit. Okay, that's a good result. If people find this difficult to understand, we can actually use the math notation like furthest is equal to math and furthest and num star I plus I. So it's essentially the same thing. Yeah, we can pretty much use whichever we want to.